Hi there, in this video I'm going to go through how to work out the equation of the plane formed by or containing three fixed points. In the previous video I went through the way in order to work out the normal vector n of that plane. So the normal vector n is AB cross AC, okay? And to work out capital P, the scalar, it's A dot n, that is the formula. But remember, A is the position vector of a fixed point on your plane, and you have three to choose from because all of these three vectors are all fixed points on your plane. Okay, so let's go through some examples explaining this approach. So let's call this example number 1. Let me underline this. Okay. So the question being, let's calculate the equation of a plane formed by the points A, B, and C. So these are vectors relative to the origin, so these are all position vectors relative to the origin. So let me call this part A. So let me give them as points. So A is 1, -1, and 1. B is given by the points 2, -4, and 3. And C, that is given by the points 0, 1, and -3. Okay. So in this case, remember the formula for the equation of the plane. So let me go back slightly. So in scalar product form, the equation of the plane formula is R dot n equals capital P. Capital P is A dot n. Okay. So if we go back to the previous video, to work out n, it's AB cross AC. So let's do this, and let's call this step number 1 to work out n. So A as a coordinate is 1, -1, 1. So the vector OA is 1i minus j plus k. B as a coordinate 2, -4, and 3. So the vector OB, that is 2i minus 4j plus 3k. And C as a coordinate 0, 1, -3. So the vector OC is 0i plus j, so plus 1j minus 3k. Okay, so I wrote these points as position vectors with respect to the origin. So using these vectors, let's calculate AB. So remember, vector AB, the quick idea of doing this, so I mentioned this in the previous video. To work out AB, it's O of the second letter is B, minus O of the first letter is A. So it's O of the second, so second letter is B, minus O of the first letter A. Okay? So we have OB, that is 2i minus 4j plus 3k, minus, and OA, that is I minus j plus k. Okay, so if we add up the like components, 2i minus I is I, minus 4j minus of a minus j is minus 3j, and 3k minus k is 2k. Okay, so that is the vector AB. We also need the vector AC, so let's calculate that. AC, so using the same idea here, remember the quick method, it's O of the second letter, which is C, minus O of the first letter, which is A. So we have OC, that is J minus 3K, minus the vector OA, that is I minus J plus K. And once again, if I add the like components, I only have one I component, it's minus I. As for the J components, J minus minus J is 2J. And adding the K components, minus 3K, minus K, minus 4K. So that's the vector AC. Okay? So we haven't finished step number 1. We need to work out the normal vector n. So remember, to work out the normal vector n, let's remind ourselves, it's AB cross AC. So when you work out the cross product, we need to work out the determinant of a 3x3 matrix. Okay? So let's go ahead. So in this case, let's write down the determinant. The top row, so the first row, we write down the unit vectors I, J and K, so they always appear in the first row. In the second row, these are the coefficients of I, J and K in AB, okay? As we're doing AB, remember, cross AC. So first you need to write down the coefficients in AB, okay? And the coefficients in AB of I, J and K are 1, minus 3, 2. So 1, minus 3 and 2. And finally, the coefficients of I, J and K in AC are minus 1, 2 and minus 4. So minus 1, 2, minus 4. Okay? So I like to expand using the first row. So the signs for the first row of the determinant of a 3x3 are plus, minus, plus. Okay? And when you expand using the first row, it's plus I multiplied by the determinant of a 2x2 matrix, whose elements can be found by crossing out the row and column associated with I. So cross out the row and column associated by that first element I. We have minus 3, 2, 2, minus 4. So it's minus 3, 2, 2, minus 4. Okay? Minus J multiplied by another 2x2 determinant, whose elements can be found by crossing the row and column associated with J. So if you cross out the row and column containing J, you can see 1, 2, minus 1, 4. So 1, 2, minus 1, minus 4. Okay? Plus K multiplied by the determinant of a 2x2 matrix. And if you cross out the row and column associated by the third element K, we can see 1, minus 3, minus 1, 2. So 1, minus 3, minus 1, 2. Those are the elements of that determinant. Okay? So continuing from there, so we're going to have I multiplied by, so when you expand a 2x2 determinant, it's going to be multiply the elements along the red leading diagonal, then subtract and then multiply the elements along the green lateral diagonal. So it's red minus green. Okay, so we need to multiply the elements along the leading red diagonal, then subtract, then multiply the elements along the green lateral diagonal. Okay, so let me just highlight these diagonals using these colours. So if I multiply the elements along the red diagonal, minus 3 times minus 4 is plus 12. Then we subtract, multiplying the elements along the green diagonal, 2 times 2, 4. Okay? minus j, open a bracket, multiplying the elements along the red diagonal, 1 times minus 4, minus, then multiplying the elements along the green lateral diagonal, 2 times minus 1 is minus 2, with that minus is plus 2. Plus k, open a bracket, multiplying the elements along the red leading diagonal, 1 times 2 is 2, minus, then multiply the elements along the opposing diagonal, minus 3 times minus 1 is plus 3. So if we simplify further, 12 minus 4, that's 8, so 8i. Okay, minus 4 plus 2 is minus 2, times minus j is plus 2j, and 2 minus 3 minus 1, so minus k. So that is the normal vector n that we found. Okay, so that completes step number 1. Now in step number 2 we need to work out the scalar p. P is a dot n, and the choice of a is up to you because all of these are fixed points on your plane. Okay, so let's go over step 2 over here. So here is step number 2. So capital P is a dot n. I'm going to take my fixed point a in this result to be OA. So OA is I minus j plus k. Okay, so it's I minus j plus k. So I'm going to take it to be OA. Okay, so we know n from step number 1, that was 8i plus 2j minus k. So 8i plus 2j minus k. So n 8i plus 2j minus k. So if we replace in this result here, we're going to have a, which is I minus j plus k. Taking a scalar product of that with n, 8i plus 2j minus k. And if I multiply the coefficients of I, j, k and then add, so I'm going to have 1 times 8, that is 8, plus minus 1 times 2, minus 2, plus 1 times minus 1, minus 1. So simplifying further, 8 minus 2, 6, 6 minus 1, 5. So that is the value of p, the scalar. So that takes us to the last step, step number 3. So remember the formula in scalar product form, the equation of the plane. Formula was r dot n is equal to capital P. So all what needs to be done is to substitute our results in. So we're going to have r dot n in step number 1. So that was 8i plus 2j minus k. So 8i plus 2j minus k. That is equal to capital P, which is 5. Okay. So that completes that example, and here are the steps in order to work out the equation of the plane which is formed by or which is containing 3 fixed points. Okay.